Hi, this is Fan. For our final project, we wrote a program that deals with airports, airline, and routes data from open flights and ultimately determine preferred routes by implementing the shortest path algorithm using the airport data. The users are expected to give some constraints passed as arguments to the program in order to retrieve the best routes. For instance, users must at least provide an airport ID as the starting point to take off and its corresponding destination airport ID. Our program will also allow users to give other constraints such as specific airline ID. We'll output the result in command line consoles. In this final project, we use the Dijkstra algorithm to determine the shortest path between two nodes. The graph will be directed and weighted. In Dijkstra algorithm, we put cumulative weight of nodes as distance, and we put them in the priority queue, and we also find the minimum distance. If the user didn't specify the constraint of the shortest path, then we'll do a BFS traversal to present a possible path from the starting point to the destination. We also implemented the landmark path algorithm, which is the shortest path from A to B through C. The user can provide intermediate point between starting and ending points, which the route must pass through.
This is Peng Han. I'll start off by introducing how we initialize the graph using the dataset we have. These dataset can be passed in by the user or by the default values. Those are the default ones that are stored automatically. To do this initialization, I created a object called graph initializer, which received a graph reference because we want to modify the graph by inserting the edges and vertices. Basically, the process can be break down into 3 steps, but before that we have to have a parse by comma. That's how we read the file, because we assume all the datasets are in the form of CSV. And then in the first step of initialization, we populate the vertices using the airport dataset. It'll look like this. And these entries are the information for each airport. In the second step, I connect these vertices. That means that we populate the edges vector in the graph class. The graph class is almost the same as the lab we did. In the third step, we initialize the edges here. This one is different from connected vertices because initializing edges meaning that we have to populate all the airlines in each route. Because there can be multiple airlines in the same route, I specifically add a vector of airlines in the edge class. I also create a class called airline, which stores the basic information of an airline. These are from the airline dataset. Something looks like this. And lastly, we definitely encountered some difficulties when we trying to initialize the graph. For example, one of the toughest one is there can be some undefined or empty value. For example, like this one is just a empty line that we have to deal with. To resolve this, we added a simple checker that detects if that entry has a number or not. If not, we just continue to move on to the next row.
Hey, this is James. I'm going to talk about algorithms we use. So the first algorithm I'm going to talk about is BFS, which will find all possible routes between start and end. We initially use Q to hold vertices and use 2D vectors to hold the paths, but we find that it's super hard to implement and it's really hard to track routes. So instead, we use Q to hold vectors of vertices and to avoid cycles for each adjacent airport, we find if that airport if it's already exists in the existing vectors. And because the traverse takes a long time, to the end we implement the max number of airports that we want to traverse through. If the num reach the limit, it will end. It will only return the airports or the paths that's within the limited number of airports. And the second algorithm I'm going to talk about is Dijkstra, which is implemented by Fan. Use distance as weight because travelers doesn't want to travel a long distance. Say, if I want to travel from Los Angeles to Chicago, travelers doesn't want to travel from Los Angeles to Beijing, then to Chicago, but instead they want to travel from Los Angeles to Dallas, then to Chicago, if there's no direct path between Los Angeles and Chicago. We encounter many issues because we want to use map and primary key. Our key is not the primary type. We have to implement to the vertex the less than and equal operator The second issue we encounter is that we try to use insert key to insert the routes, but we find out that if the keys already exist, we cannot insert the key with new values, so we override it with the bracket operation. And for the landmarks, we break it down to from start to the middle points and from mid to the end, and we find out the routes in between.
For the testing, we have two sections. One of them is test for initialization part, and the other one is for the algorithm. Initialization is just pretty simple ones. For example, I tested parse by comma, testing the weight, testing the edges, something like that. For the algorithm, I actually made up some sample data sets that I can use for testing. Those are selected from some familiar airport that I know, and I can verify if that's indeed the shortest path between those two airports. For example, for Denmark, I must have a start, end, and landmark is the fifth airport, and I can confirm that it matches the expected airport path. And that's pretty much it for testing.
Now I'm going to run the program and present the outcome of each deliverables. So first we make, and then we run final project. And now we have to choose whether we have to use the default file or use our own file. Now I will choose the default file. Okay, so now we have the options listed below. So for the first one, we test to find out possible passes between two airports. We hit 0, and I will use the example that I found before. So I entered the ID for the two airports, and then there's a constraint about number of stops, and I will enter 1. Now the listed below are available passes from these two destination and departure, and we hit 1 to continue. And the second deliverable is find the shortest path between two airports, and we enter IDs again. Now we have the option to choose a specific airline. I will first test the option to have the constraint. So I will hit the ID for a specific airline, and this path is the airline with departure and destination listed above. Afterwards, we'll test with no constraint. So we'll do it again. So we just hit 0 here. And this algorithm uses the search algorithm to find the shortest path, so it may take a short while. So now we have the direct path from these two airports as the shortest path. And finally, we'll test the third option, which is the landmark algorithm. Again, this have two options with constraint or not. So we'll test first with the constraint. And we use this ID as the landmark. So this path listed above is the output path for the departure and destination airports with landmark in the middle. As we can see, there's two identical airports listed here. At first, we thought it was a bug that our algorithm may contain some cycle, but actually it's not. For reference, we can look at this graph. So this path basically looks like some graph like this. We are constrained the landmarks as C. So in order to go from A to E, we have to first go to B and then go to C and then go back to B. So that's why we have two identical airports in our path. We implemented all of the functions we initially planned, and we thought we met all of our goals successfully.